The homework tonight is on page 409, uh, 2 through 54 even. Tomorrow night's homework is on 409, 1 through 53 odd. I am recording this lesson for those guys that are away, and I'm going to be using this worksheet with some of my examples, so that's why I'm giving it to you. My question up here says, what's the inverse of 2? Anybody? The inverse, the multiplicative inverse of 2. 1/2. Right. So what's the inverse operation of the square of a number? Square root. Inverse operation of the cube of the number is the cube root of the number. Inverse operation is x to the fourth. Is the fourth root of x, and the nth root of x if it is x to the n power. So having said that, I'd like to go back and look at x squared. The square root of it, square root of x is, like we said, the inverse. Well, the inverse of the number 2 is 1/2. So x to the 1/2 power is equal to the square root of x. So x to the 1/3 power is equal to the cube root of x. X to the 1/4 power is equal to the cube root of x. So x to the 1/n is equal to the nth root of x. So that's why I have written up here the square root of x is equal to x to the 1/2, the cube root of x is equal to x to the 1/3, and the fourth root of x is equal to x to the 1/4 power. So I have an example of the square root of 64. That is equal to, y'all all know that's equal to 8. We could write it as 64 to the 1/2 power. They mean the same thing. The cube root of 64 is 64 to the 1/3 power, and the fourth root of 81 is equal to 81 to the 1/4 power. Well, let's take this another step. We know the answer is 8, but this is 8 squared to the 1/2 power. So 1/2 times 2 is 1. 4 to the 3rd power raised to the 1/3 power is equal to 4. The cube root of 64 is 4. 3 to the 4th power is equal to 81 to the 1/4 power. So the fourth root of 81 is 3. You have a blue sheet with that information on it. You need it. Okay. So the next thing, I just have a chart with the same information on it. But I like to go over this information. The number underneath the radical sign is called a radicand. This little bitty number up here is called the index, and this is called a radical sign. It is not a square root sign, it is a radical sign. So on the top of this piece of paper I gave you is some information that is similar to what I have up here. If x is equal, and you need to take this down, this is something you've got to know. So if x is equal to 0, then the nth root of x is 0. So in other words, the square root of 0 is equal to 0, the cube root of 0 is equal to 0, and I can continue on. Here, if x is greater than 0, then the nth root of x is a positive number. What this is saying is that if x is greater than 0, meaning it's a positive number, then this is equal to 8. This, of course, would be equal to 4. And I could go on. The ones that are important are the next two rules. And I have stars by these because you have to understand them. If x is less than 0, meaning it is a negative number, and the index is odd. The index is odd. This is important. Then the nth root of x is a negative number. So here I have the cube root. That index is odd. Negative 64, so the answer is negative 4, because negative 4 times negative 4 times negative 4 is equal to negative 64. Here I have the fifth root of negative 32, and the answer is negative 2. That's because negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is equal to negative 32. Next it says, if x is less than 0, meaning it is a negative number, and the index is even, then the nth root of x is not a real number. That is the only answer you can put. Do not put not possible, because it is possible. It actually is an imaginary number. And we won't talk about those for a while. So I have the square root of negative 64 is not a real number. The fourth root of negative 625 is not a real number. Now, once again, it's important to remember that the index has to be an even number. Obviously, if there is no index, it's understood to be square root. If there is an index and it is even, and the number underneath the radical sign is negative, then the answer is not a real number. Everybody good? So, let's look at a few examples. Once again, we're looking at the cube root, the fourth root, the nth root. The principal root is when there is more than one root and the index is even, then the principal root is a non-negative number. So the square root of 81 is equal to 9. The cube root of negative 343 is equal to negative 7. And you'll notice the next one says plus or minus. Here you're looking for both the positive root and the negative root. So maybe I'll put plus or minus, and we get plus or minus 6. Next I have negative square root of 36. That's asking for the negative root. Here you're asked for the negative root, so the answer is negative 3. And this is not a real number. So now I'd like to look at these next problems. This one is actually number 4 on your worksheet. And this one, which is also on your worksheet, I'd like to look at these. The difference between these and the ones we just looked at are the fact that they have variables. So we're going to actually down here. The way this works is if you divide the index into the exponent, get what I call the outside number. And the remainder is what remains inside. So we'll start by taking the square root of 4. The square root of 4 is 2. But then if you divide 2 into 10, it goes evenly. So we know that this is a to the 5th. There is no remainder, so there's nothing that remains underneath the radical sign. Everybody okay with that? So here, now maybe I'll work it another way as well. The other way to look at this is that's 2 squared a to the 10th, raised to the 1/2 power. The rule tells you to multiply your exponents. So what's 1/2 times 2? 1, and 1/2 times 10. Okay, everybody good? All right, so up here, I have 243. Well, if you look on your blue sheet, you'll see that that is 3 to the 5th power, p to the 10th. Okay. So once again, if you divide your index into your exponent, you get 3 to the 1st power, p to the 2nd power. Or you could, like I said, rewrite this. I think sometimes this is actually can be easier, not always. And you get that. There is a little rule that I've overlooked just by doing this that I need to go over. And I call it even, even, odd. That's not really its name, but that's what we're going to call it, even, even, odd. So wait till you get these examples on your paper. I'm going to start with this one. Okay. We just said that we would divide the index into the exponent, and we would get our answer, right? Everybody agree with that? But that's not the answer. That's not the answer, because that tells you the answer is -5. And that's not the answer. Because if you square this, -5 times -5 is +25, and the square root of that is 5. So when the index is even, when this is even, and your answer is odd, you need absolute value symbols. Everybody understand that? Even, even, odd. Even, even, odd. Okay. All right. So here, this is even, and this is odd. So you need absolute value symbols. And the reason is you don't know whether x is a positive number or a negative number. Okay. Here, we got an even, and 4 goes into that 3 times. Your answer is odd. So we have the absolute value of x cubed. Everybody good? You only need this when the index is even. You don't need it when the index is odd. because when the index is odd, you can have a negative number for an answer. Nowhere in the real number system can you multiply two negative numbers together and get a negative number. Okay. So, let's look at this example that I have up here. Once again, the easiest way, I think, sometimes to write this is to rewrite 16 in terms of 2 to some power, which y'all all know the square root of 16 is 4. 2 goes into 10 5 times, and 2 goes into 8 4 times. We don't need the even, odd rule except for on variables. We don't need it for 4, but this is even, that is even, and this is odd, so we need that. This is even, so we don't need it. Everybody still with me? All right. Well, nobody's asked when the index doesn't go evenly into the number. All right, so we've got 3 into 17. Well, it goes 5 times with 2 left over. And this is why I call this the outside exponent. And this is left the exponent, which is inside the radical sign. So nobody does this. So this is x cubed times x cubed times x cubed times x cubed times x cubed. 1, 2, 3, 4, 5 times x squared. So you could actually find the cube root of this, the cube root of that, the cube root of this, the cube root of that, and the cube root of this. And you'd have 5 x's, wouldn't you? But you can't find the cube root of x squared, so that's why it remains underneath the radical sign. So that's why I said if you divide the index into the exponent, that becomes the exponent for what's left on the outside, and this becomes what remains underneath the radical sign. Everybody understand that? You sure? Okay, so looking at the next problem, which is down on number 22 on your worksheet. I don't really care what's inside these parentheses. Okay? What I care about is dividing the index into the exponent. So how many times does 2 go into 2? Once, right? So whatever's inside those parentheses is still inside those parentheses. But I have an even, and an odd. So I need absolute value symbols around it. Are y'all still with me? Let's look at this problem. Notice it's a trinomial. You got to factor it. So we're looking for the factors of 36 when multiplied together give us 36 and add together give us negative 12. Come on, somebody. Negative 6 and negative 6. So 36 over negative 6 gives me 6 over negative 1. So I have 6x minus 1 times 6x minus 1. So this is really the square root of 6x minus 1 squared. So now it looks like the problem we just did. So we would want to divide the index into the exponent, and we get 6x minus 1 inside the absolute value symbols. Okay? Everybody still with me? Y'all are looking kind of tired. Alright. So let me put one up here and y'all handle it. Let's say you had alright, see if y'all can simplify that. Well, the square root of 64 is 8. 2 goes into 4 twice. 2 goes into 6 3 times. 2 goes into 7 3 times with 1 left over. Once again, we have to check because we have an even exponent. So that's even, 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 odd. And the next one's even odd, so we don't care. In simplest form, the answer to this is 8x squared, the absolute value y cubed, z cubed, the square root of z. How'd y'all do?
Wait, isn't it even? Oh, never mind. I'm mistaken then. I didn't think about this 7 being odd.
Alright, so on the next problem I have the cube root of parentheses 5a squared b inside the parentheses raised to the 6th power. Y'all, do not raise all of this to the 6th power. Don't even look what's inside the parentheses. Okay? You want to divide the index into the exponent, so you want to divide 3 into 6. It goes twice. So you get 5a squared b squared. And then if you want to raise these to the power and get 25a to the 4th, b to the 2nd, that's fine. But this is an acceptable answer. Everybody's still okay? So here are a number of problems that I put up here for y'all to work. So I'll give you a few minutes to do that. You have a blue sheet, you're probably going to need to use it. If you don't have a blue sheet, you need to raise your hand. Let me give you another one. again, if you divide the index into the exponent, you get 3. This is even, that's odd, so we need absolute value symbols. Divide the index into the exponent here, and you get x to the 5th. This is even, that's odd, so we need absolute value symbols. On the next one, you see where I wrote 32 in terms of 2 to the 5th power. I just think sometimes that's easier. I know that 5 goes into 5 once. I know 5 goes into 15 3 times, and into 24 times. The index is odd, so I don't need to worry about little even, odd rule. So that is the answer to the problem. On the next one, I have the 5th root of 128, which is the same thing as 2 to the 7th power, x to the 17th, and y to the 21st. So I know that 5 goes into 7 once with 2 left over. So I'll have 1, 2 on the outside, and I'll have 2 left underneath the radical sign. I divide 5 into 17, goes 3 times, with 2 left over. So I have x cubed with x squared underneath the radical sign. 5 goes into 21, 4 times, with 1 left over. So I have y to the 4th, with 1 y left underneath the radical sign. So in simplest form, this is 2x cubed y to the 4th times the 5th root of 2 squared x squared y to the 1st. How y'all doing? Everybody okay? Looking down at some other examples, these are all pretty much what we've already done. And but I would like to look at this problem, number 15. So we'll do numbers 12 through 15. I don't think any of these are on your worksheet. They're ones that I just made up. When the index is even, you have to worry about the little rule, even, odd. So if we divide 2 into 6, what do we get, y'all? 2 into 7 with 1 left underneath the radical sign. But this is even, odd. I need absolute value symbols around that one. And here I have the square root of 25 is 5. 2 goes into 8 4 times. And 2 goes into 9 4 times with 1 left underneath the radical sign. This is even. So I don't need any absolute value symbols. On the next one, if I divide 4 into 12, I get 3. If I divide 4 into 16, I get 4. But this is even, odd. I need absolute value symbols. On the next problem, we'll talk more about division in a day or two. But I'm going to rewrite this. I think it might make the problem easier. I know that the square root of 25 is 5. I know the square root of 16 is 4. I divide the index into the exponent, I get 1. But once again, it is even, odd. I need absolute values around it. Everybody's still good. Alright. So I'd like to go back to just your calculator real quick. So that you know the easiest way to work these on a calculator. The first one I have up here says the square root of 7.8. On that particular problem, I know that the square root of 9 is 3, and I know the square root of 4 is 2. So this number, whatever it is, has to be between 3 and 2. Everybody understand that? Alright, so you can all put that in your calculator and push the buttons. I put my decimal place on 3 places, and I get something that looks like 2.793. Okay? But I like to look at this problem that I have here, which I don't know why it says 6, but it does. I want to look at this problem because there's all kinds of ways to put this in your calculator, but the easiest way to put this in your calculator is to put in the number, and I'm going to put parentheses around it, negative decimal 0, 1. Oh no, wrong. That should be 0 decimal 1. Alright, close the parentheses, and caret top, parentheses. You gotta have the parentheses, 1 divided by 5. Okay? And you get your answer at negative decimal 6309, whatever. Okay, everybody okay with that? Okay, if your calculator is on, going to mode, if your calculator is on math print, okay, I think you could do this. I really don't like, no, you can't. You can hit second math, not second math, or just math. Yeah, just math. I really don't like this because it takes so long to go down to 5. And do you see where on math print you can put in 5 and then put in the number negative 0.1 and get an answer. But I don't like the math print mode, so I leave mine on classic. In which case you're going to have to put in a caret top. Everybody understand that? Alright. Now I'd like to go back to last night's homework and call out the answers.